Hey guys. So in my last video, I said some things about the ancient Greeks that weren't very nice. I think I said that they were lazy, and if they were so smart, how come they're all dead? It wasn't a great look. So today I'm going to start with an apology. To all the ancient Greeks out there, I'm sorry. I shouldn't have said what I said. You guys invented philosophy and the Olympics and hero sandwiches, and all those things are great, and that's why we love you. Also, your system of the four elements has been the basis of at least one really good cartoon, and that's not terrible. That's not nothing. And even though that system is totally wrong, it's not totally wrong. There was a way in which you were kind of onto something. So, just as a reminder, what the Greeks believed was that the world was made up of four elements: air, earth, fire, and water that made up all the stuff. Like everything in the world was some combination of those four elements. Now, that's clearly wrong, and one way to prove it is to think about ice. So when you pull a chunk of ice out of the freezer, it's hard. It's a rock. So obviously it's earth. But if you leave it on the counter overnight, it turns into water. And if you boil it, it turns into steam, which is a type of air. So somehow ice is earth and water and air all at the same time. So, what is it, a werewolf? And the answer is yes, ice is basically a werewolf. Ice is like Jacob from Twilight, who had the power to turn from a wolf into a boy who couldn't act. But water is actually better because it can take on three forms, or phases as we call them: solid, liquid, and gas. And it turns out every other type of matter can do this too. Every type of matter can take on the three phases. So for instance, when solid rock melts, it becomes lava. When carbon dioxide freezes, it becomes dry ice. When butter melts, it becomes delicious. So three of the Greek elements, earth, water, and air, actually correspond to three phases: solid, liquid, and gas. But what about the fourth element? What about fire? So it turns out that most of these physical changes, which is what we call it when you go from one phase to another, melting, boiling, freezing, it turns out on the molecular level, these changes are kind of a nothing burger. Like imagine you're this hydrogen on the right. The molecular structure of water and ice is this, but in water it's this, but in steam it's this. So from the perspective of that hydrogen, going from ice to water then steam is completely pointless. Like your Facebook status never really changes. But now let's imagine that a fluorine atom comes along, because fluorine is of course the fleekest of all atoms. So obviously if this hydrogen can, it's going to want to get away from this oxygen and go hang out with that fluorine. So now the hydrogen's status really has changed. Now it's in a different molecular arrangement. And we call this type of change a chemical change. Now it turns out that when you react water and fluorine in this way, what you get is this jet of gas that is so hot that it actually glows, which is what a flame is. A flame is a jet of superheated glowing gas that results from certain chemical reactions. So three of the Greeks' elements, earth, air, and water, are phases that can change from one to another in physical reactions, and the fourth element, fire, is what you see during a chemical reaction. Fire is one of the hallmarks of a chemical reaction. So that's what I mean when I say the Greek system of elements wasn't totally wrong. I mean, it's not like hero sandwich good, but it's not terrible either. Anyway, here's your summary for this week. A phase is one of the three forms that matter can take: solid, liquid, or gas. A physical change is a change between phases. Melting and boiling would be two examples. A chemical change is a change that rearranges atoms in a molecule. A fire is a glowing jet of superheated gases produced by certain chemical reactions, and fluorine is the fleekest of all atoms. All right, we'll see you next time.